So we want to check the validity of our two answers because we want to double check if either of them is extraneous. So I'm going to use our first point, the root of 7/3 squared minus the root of 7/3 multiplied by 2 root of 7/3 plus 2 root of 7/3 whole thing squared equals 7. So the first term, square root will cancel. You get left with 7/3 minus 2 times 7/3 plus 4 times 7/3 equals 7. Remember that the 2 also is squared. That's where the 4 is coming from. We are left with then 7/3 minus 14/3 plus 28/3. And we want to check. We're checking if it equals 7. We don't know yet, so I'm just putting that slash mark there to see, to make sure you understand you're not supposed to do anything with it. You're just checking to see if the left side is the same as the right side. So we are left with, it looks like 21/3, which is the same as 7. So the first one it does look like is a solution. Now over here, I'm going to look at the second one. I'll start that in black. Negative root of 7/3 minus negative root of 7/3 multiplied by 2, or negative 2 root 7/3 plus negative 2 root 7/3, and we're checking if this whole thing is equal to, squared 7. So what do we get? We get the first term, you get 7/3. It does become positive. Your middle term, the 7/3 will, the root 7/3 will cancel the root. Negative times negative makes a positive 2, and I still have the minus, so minus. The middle term is positive 2 times 7/3. And then the last term, we get left with positive 4 times 7/3 equals 7. And if I am correct, that looks exactly the same as the first term, so I believe both become 21/3 equal to 7. And so I believe both of them are solutions. I'm not sure, but I believe that's not what we got in class because half of the class, I believe, told me that the first one was not a solution. I'm getting that it is, so if you can find a mistake in this recording, please let me know. We are going to look at where there are vertical tangent lines, so I'm not going to finish this entire problem. What I am going to do is steal the derivative that we had from before. And I'm going to at least get you guys started, but it's going to look very similar to the tangent lines. So if I want to find where I have vertical tangent lines, well, vertical tangent lines go up and down, therefore the slope is undefined. How can you have this slope be undefined? It's where the denominator would be equal to 0. And in this case, we actually get that negative x is equal to negative 2y, therefore x is equal to positive 2y. And so it looks very similar to what we had before. What you want to do is go back through and substitute in 2y for every time you see x. And you will solve this quadratic. You will go through and find your x and your y, and you will substitute back into the original to check for your answers. So the steps that you take to find your horizontal and your vertical tangent lines are very similar, and the key is to check for extraneous solutions. Higher order derivatives, finding a second derivative. Well, the first step is easy because you're just going to be asked to find your first derivative. So the first term, you get 6x squared. The second term, you get minus 6y, but since you're taking the derivative of y with respect to x, you have to have your differential, and you set it equal to 0. You're left with negative 6y dy dx is equal to negative 6x squared. Therefore, dy dx is equal to negative 6x squared divided by negative 6y, and you have x squared over y. Now when I am asked to find my second derivative, you're going to need what you just found a second ago. So I'm going to actually copy this onto the next page. And we are going to use this to help us find the second derivative. So, see, the derivative, of the first, the derivative would be, you'd have to use your quotient rule. So, low d of high minus high d of low all over low, low. What you'll notice is we get left with dy dx again. And you're not allowed to have that in your answer. And so what you're going to do is go back to your original derivative that you found and you substitute that in. So what it looks like is d squared y over dx squared is equal to 2xy, simplifying the first term, minus x squared, and we're going to substitute into here x squared over y divided by y squared. And then remember our rule, we're not allowed to have two fraction bars, so we are going to get a common denominator for the top term. So you would have, well, let me multiply everything out so you can actually see it. So I'm going to get a common denominator for the top term, which would be y. So the 2xy, I'd have to multiply it by y over y. And so we are going to have 2xy squared over y minus x to the fourth over y all over y squared. And some of you might be thinking I'm taking a longer way to solve this or simplify it, and it is true. And the purpose is because that way you'll be able to do some of the harder ones that we get. So there's our common denominator multiplied by the reciprocal of the denominator, which is 1 over y squared. Therefore, our final answer for this guy would be 2xy squared minus x to the fourth all over y cubed. And in all honesty, I would even factor out an x from the numerator, just so I have two factors. But at this point, there is your answer for your second derivative. So this is probably the part that is a little bit different, and you want to make sure that you substitute in the first derivative when finding second derivative.